So this is question 1c, where you've got Rosalie or Rosalie reading about space, and she's thinking about making a computer game. So you've got different companies using different rockets. Each company costs a different number of space bucks depending on how heavy the satellite is. So you've got three companies here, A, B and C. So we'll do A first. I'll just highlight what the thing. So this is for light satellites only. Here's a fixed cost of 8 space bucks, and then this is the changeable bit, is the 0.5 space bucks per kilogram. The heaviest it can be is 7 kilos. So if we go for A, so our Y, which is our cost. So our variable bit is the 0.5 space bucks per kilo. So we'll just call it X, or you can call it K for kilo or whatever. The fixed cost is 8, so we put the +8 on the end. Now there is a bit of a restriction for this. The heaviest it can be is 7. So that means that X has to be less than or equal to 7 kilograms. Okay, so that's the heaviest it can be. Sorry, X stands for the number of kilos. Y stands for the cost. Okay, we'll just change colour for the next one. We'll go yellow. Okay, so B company is for heavy ones only. So the lightest it will send is 12 kilograms, and 12 kilograms costs 13 bucks, space bucks. We'll just call them bucks. For every kilo, it costs an additional 3 space bucks per kilogram. Okay, so if we transfer that to a equation, so the variable bit is 3, so we're going to times that by X, by the number of kilos. Now what we know is that when X is 12, it's going to cost 13. So if we go for $13 and when X is 12, so that means that's 36. And to find out what C is, take 36 away from it, and we get negative 23. So therefore the equation for that one equals 3x minus 23. Okay, so we'll highlight these equations. So there's, we'll highlight that one, and we'll highlight the first one. I'll just do it in the same colour as it was before, because then it makes it clearer. Okay, now we're going to go to C. Oh, now what's the restriction on that one? The restriction is the lightest one is 12. So we're going to go X has got to be greater than or equal to 12. Okay, so for C, right, we're going to go take any satellite, but X will have to be greater than or equal to 0, of course. Oops, the other way around. Let's rip that out. Greater than or equal to 0. It has a fixed cost. Let's go another colour for this one. We'll go pink. Okay, so it has a fixed cost of 6 space bucks and then 1 space buck per kilogram. So if we can write that as an equation, so the variable cost is 1 space buck per kilogram, so we'll just times that by 1, but the fixed cost is 6. Okay, those are our 3 equations, and we'll just highlight, oops, we'll write that again, and then we'll highlight it. Okay, so what we're going to do now is draw that underneath. So sorry, we're going to flick up and down a little bit, but we'll do that. So what we'll do is set up down here. So here's our x-axis, here's our y-axis. Okay, so we'll go 2, 4, 6, 8, 10. This is our x value, which of course is the number of kilograms. 12, 14. And then at this axis is the cost. Okay, 4, 6, 8, 10, 12, 14, 16, 18, etc. Right, so now we'll go back up to the first equation. 0.5x plus 8. So our fixed cost, or our y-axis, is 8. Okay, and we're going, our gradient is 0.5, so that means for every, that we can change that to a half. So for every 1 we go up, we go along 2. So we're going to go up 1 and along 2. And we can keep doing that if we like. And we're going to join that up. But remember, there was a proviso on that, that we couldn't go, it had to be less than or equal to 7. So we have to stop at 7. Okay, so if we draw a line that stops at 7. Oops, sorry, it's a bit of a, okay. And we'll just highlight, we highlighted that colour green, so we'll highlight it green down the bottom as well. So then we know what. Okay, the next one is B, which is 3x minus 23. So we can't go to minus 23, but we do know that it started when x was 12, y equals 13. So when x is 12, y equals 13. And we know that the gradient is 3 because it goes up $3 for every kilo. So that means our 3 over 1, our rise is 3 and our run is 1. Okay, and so we can join up that equation there as well, that graph as well. And we just roll a line. Oh, sorry, it's not very, oh, you know, that's all right, that's okay. Okay, so that's for that one there. And that was our yellow graph, so we'll just highlight that in yellow. Now, my suggestion is do highlight, and then you know what ones you... Okay, and our third one is y equals x plus 6. Okay, so our y-axis, our y-intercept is at 6, and our gradient is 1. So that's 1 over 1, so that means for every one I go across, I'm going up 1. Every one I go across, I'm going up 1. And so we can just draw that through there. We'll keep drawing it through so it goes through the other graph as well. Because then we can see. Okay, and that one's the pink one. Okay, so we'll just highlight it in pink. Okay, so we've got our 3 graphs. Now what it asked us to do was use the equations with domains. So these are the domains, these are our restrictions. Okay, compare the 3 companies' costs. So we want to know what's cheapest, and it's easier to do from the graph. Okay, so the graph of A and C, this is A and this is C. That crosses at 4 when after 4 kilograms. So that means before 4 kilograms, C is underneath. Okay, so that means that's the cheapest. So C is the cheapest. Oops. Cheapest when X is less than or equal to 4. Okay. Now, when we look at the greatest cost, so then at that stage there, this pink line becomes the cheapest until we reach this value here when B comes into the market. And when B comes into it, then it is the cheapest until this point here. Okay, so we need to read from the bottom, 12 up to 14.5, because if we read down here, that will cross there. From 12 until 14.5, so when X is between, 12, not 12.5. Therefore, what was the cheapest one? B was the cheapest. And at all other times, i.e. greater than 14.5 and between 4 and 12, all other times, then A is Just check that. So that's the, sorry, I'm telling lies. C is the cheapest. So A is the cheapest, because that's the green one. Sorry, my bad.